So now, for the angle side theorem, very similar to the last one we just did, but what we want to consider is, and I'll draw a little bit different triangle. Let's draw this one, okay? And we need two angles and then a corresponding side. So I'll draw them out like this. If this angle is congruent to this angle, and this angle is congruent to this angle, and then the remaining side is congruent, then it would work, right?
Yeah.
So we would have an angle, right? Then we would have another angle, and then we would have the side. Okay? And the way this one works is, if I say A, B, C, and this is D, E, F, then the angle side postulate is if angle A is congruent to angle D and angle B is congruent to angle E and line segment BC is congruent to line segment EF, then somebody finish the sentence. Very good. Then triangle ABC is congruent to triangle DEF. Does that make sense? So same thing. We could rotate. We could go clockwise or counterclockwise, but it has to be an angle and an angle. Those have to correspond. They have to be congruent. And then the side that follows those two angles has to be congruent. And then you can prove congruent triangles. So let's look at example number 2 out of your textbook. Or actually, this is problem number 3 out of your textbook. I kind of skipped example number 2. So this is example number 3. Maybe we'll go back and do number 2 separately. So I have an object that kind of looks like this. I'll draw it a little bigger there. And that object really kind of looks like this. And they tell us that these lines are parallel and that this angle and this angle are congruent. And we'll label this is W, M, R, K. Okay, and then they give us this. Give it. Angle M is congruent to angle K. Why can't I draw the letter K today? And the line segment WM is parallel to the line segment RK. Can't draw a K today. And then they want us to prove triangle WMR is congruent to triangle RKW. And this is the section of angle side. Okay? Now, there's a clue that they give us here. And what I'm going to do is I'm going to consider a couple of things. One, they gave us a clue that these two lines are parallel. So I want to consider that. And I'm going to draw this a little different. So if these two lines are parallel, that means this line can go on forever. We're going to imagine that this line could go on forever, right? And I know it's yellow and you can't really see it, but I don't want to take away from the... and this line goes on forever in both directions, okay? So those lines are parallel, they never intersect, it goes on forever that way, right? And then, here's an interesting thing. This line is kind of like what? Well, it does intersect the two parallel lines, but this is a transversal, right? Okay? So since that's a transversal, and we have parallel lines, first of all, we need to prove the triangles. We need to prove the triangles. We need to prove the triangles with angle, angle, side. We need to prove the triangles with angle, angle, side. I have an angle here, right? First of all, where's the congruent line segment? Does anybody want to tell me which line segment would be the congruent line segment that both triangles share, that we could prove beyond a shadow of a doubt? Yes?
Would that be line WR?
Yeah, WR is the congruent line segment for both triangles. Does everybody agree? All right, cool. All right, so I've got my side, right? So my side is just going to be the line segment WR, because that's congruent for both triangles. Well, my first angle right here is going to be angle M, which is also congruent to angle K. And I need angle, angle, side. So I need to prove, it doesn't matter which one, but I'll give you an example. I need to prove that maybe this angle is congruent to this angle. I need to prove that. Okay? Well, because the lines are parallel. Yeah, well, it's not corresponding angles. What type of angles are those?
Alternate.
Yeah, they're alternate interior angles for sure. Well, wait, let me think this through.
So it's on.
Technically, the textbook is wrong.
Oh, dang.
Well, I chose the wrong angles. See, I can't use these angles. Do you know why?
No.
Because it's got to fall back on the on our parallel lines. So technically, I've got to choose. It wasn't the textbook was wrong. Mr. Adams was wrong. I got to choose these angles because those are alternate interior angles that I can prove. Does that make sense? So when I do it this way, it's a lot easier. It's still the same thing. I've got angle, angle, side, and then over here I've got angle, angle, side. But I need to make sure that my angle has that parallel line and the transversal. And so the way I had it before would not do that. So it's kind of good that I kind of haphazardly made that mistake because you might be tempted to do the same when you do your homework. Okay?
So which line do you use then?
Well, we're going to write it all out in a second. So anyways, we've got what we need. So let's start the proof. So we're going to do a T-chart. So we have our statement. And then we have our reason, and then I'll go in greater detail as to what we're doing. Okay, so first thing we got to list the given stuff, right? So, boy, I don't want to rewrite all that stuff. Can I just do this? Yeah, let's just do this and then clone it. And then I'm going to drag it all over here. Maybe I'll shrink it down, put it together, shrink it down a little bit, and we'll pull it apart. So all this stuff was given, right? Oh, I'll just write it out. It's taking forever. So we know that angle M is congruent to angle K. We know that WM, the line segment WM, is parallel to RK. Okay, we know that. That's given to us, right? So then we had to say that RW, line segment RW, is congruent to line segment RW. Does anybody remember what proof that is? Or property?
Reflexive.
Reflexive, right? When you look in the mirror, you see your reflection, you see yourself. So this is the reflexive property of congruence. Okay, that's done. And then the last thing that we figured out was angle MWR is congruent to KRW, angle KRW, right? Which that's just alternate interior angles of parallel lines, right? And so I have my angle, right? So I have, just to recap, I have an angle here, and I have another angle here, and then I have my side. Probably if you were to write the proof, you probably might want to swap this step here with this step, but it doesn't matter. So then I could say triangle. NWR, or WMR is how they worded it, is congruent to triangle RKW by angle, side postulate. Does that make sense?